layered architecture style, or sometimes it calls layered pattern. This is the granddaddy of all patterns, architectural styles. Generally, it is de facto standard for most application, primarily because it is quite simple. It is a lot of developers familiar with them, and the cost of this solution is quite low. So it's very natural for the developers to work with this approach, and most of the organization, they use interface as one of the layer. Backend developers use backend as another one layer, and database developers, they have different layers. Sometimes this layers approach is called n-tier architecture style, or layered architecture style, or layered architecture. Different meaning, different names, but the same meaning of all of them. So we are talking about different layers that are independent, and can be, each of them can be replaced. What is the topology of this architecture style? It is that components within the layer architecture style are organized into logical horizontal layers, with each layer performing a specific role within the application. So it can be presentation or business logic or persistence logic. There are no specific restriction in terms of number of and types of layers that should be present in your system, but there is like a standard that's applied in the industry, that you will have generally 4 layers. It is presentation layer, business layer, persistence layer, and the database layer. In some cases, a business layer or persistence layer are combined into a single business layer. It depends from what kind of technology stack you are using. If we are talking about, for example, Spring Data set, then sometimes you can see that they are combined in a single one layer. Or when the persistence logic is embedded within a business layer components. Some small application, they can have only 3 layers, or where, for example, you can see, for let's say, presentation layer, and some logic will be, instead of business layer, putting into the persistence layer. So it can be different combination. Also, various topology variants from physical layering or deploying perspective present here. Here you can see, for example, that we have as a one single unit the presentation layer, business layer, and persistence layer, and database layer is another one unit of deployment. Sometimes it can be divided in next way, that presentation will be split as a separate deployment, which is not for example, let's say here presentation layer is a part of all of this stuff. It's, let's say, you will use GSP pages on Java, and you will write the pages on the, let's say, backend side as a deployment unit where they will be, during the compilation time, changed to HTML pages. So it is GSP pages. And it will work. Or you decide to replace presentation layer and use React, for example, then you decided to make it in a separate deployment unit. Yes, you can do it. It still will be the layered approach, layer architecture style. Or even you can combine all of them into a single package and deliver for the customer as a single deployment unit that will contain everything in one package, in one archived. The database layer, presentation layer, we're not talking about here generally about the Dockerize, about the Docker. No, it is not. The monolith is not require this. It can be archived into the such extensions as ER or var or something like this. In most cases, for on-premise clients, you can use the third one. So when they expect everything in one package, yes, it can be, but it depends on also on situations. Yeah, before we'll switch to the layers of isolation, maybe I just if you were, I will add a few words to the previous slide that generally the separation of concerns concept within a layers architecture style make it easy to build effective roles and responsibilities model within the architecture. So your components will be limited to some specific layer, and they are limited in some scope, dealing only with logic that is designed for them. They are not, they haven't be busy with different logic that other component is responsible for. So and also another one is that the layer architecture is a technically divided architecture. So it means like components grouped rather than being a group by domain, they are grouped by their technical role. So it means here you see that they are grouping, not like, for example, this component is grouped by for the orders and it will responsible only for orders, or this one will respond only for profile or something like this. No, in this way all of this functionality grouped by what from the technical point of view they are doing, they're responsible for they're responsible for presentation layer, for they're responsible for business layer or persistence layer. So here we see the layers of isolation. Each layer is a layered architecture style, can be either closed or open. They can have two states. And the question is, what should we do? How it should be designed? And what it means, first of all, a closed layer means that as a request moves top down from layer to layer, the request cannot skip any layers, but rather must go through a layer immediately below it to get to the next layer. So you are not able to skip one of the layer and for example, from the presentation layer, get send request to persistence layer. If you will try to do this, so what is the consequences of doing? Why we should not skip this? Is it a good approach or not? If you will skip and, for example, do something like yeah, I will show you next slides when we will try to add some layers. But if you will try to make this layer open and bypass some layers, with which things you can face. The layers of isolation concept means that changes made in one layer of architecture generally don't impact or affect components in other layers, providing to contract between these layers. And this contract should be unchanged. And each layer is independent of other layers. So if you will broke this and make some changes for persistence layer, you will add additional methods. For example, here, then it means you have to change the contract not only with the business layer, but you have to change the contract also for the presentation layer. So it will build additional dependency between layers, and the changes and the idea of communication between layers will be broken. To be short, always try to keep all of these layers closed. It means that only with the persistence layer, only with the business layer can works, and with the business layer, presentation layer should work. And if presentation layer want to do something with database, it should go through all of them without skipping someone. Yes, you can mention and say, okay, if you will go through all of these layers, it will influence the performance. It will spend some time for this. Yes, it will, but the amount of time that we will spend through the through falling through all of the layers is not quite significant. So let's imagine a situation that we are trying to add some layers. Suppose there are like, what is the situation? Suppose there are a shared object within a business layer that contains common functionality for business components. So here it is, shared component. And suppose there is an architecture decision stating that the presentation layer is restricted from using these shared business objects. So this is the dotted lines, the red line with dots. It shows that you want to get access to the shared components, but if you will do this, you will broke the statement that this layer is closed, and you have to go through all of the layers significantly. Not significantly, sorry, like in sequential order. So what the solution can be? How can you resolve? One way to mandate this restriction is to add to the architecture a new service layer. And adding new service layer architecture will restrict the presentation layer from accessing the shared business object because the business layer is closed. However, the new service layer must be marked as opened. So we will restrict this communication. We will not allow to get access from the presentation layer to shared components, but still so what we will do, we will make additional layer, let's call it service layer, that will be present between business layer and persistence layer. And we'll make it open because what? So if we will not make the open, then the business layer will be forced to go through the service layer to access the persistence layer. And marking the service layer as open allows a business layer to either access that layer, it is this one red line, or in some cases bypass the layer and go to the next one down. So in this case, it makes sense to make this layer as open, because in some cases, business layer doesn't need to go through the shared component to the persistence layer. In some case, it should. So business layer will have ability to choose in which situation they should use service layer and which situation it should not choose the service layer. Basically, this is one of the typical situation. So if you want to make the layer open, it can be, I think, as a service layer, but it's hard to imagine that persistence layer will be open or database layer will be open. Now let's try to see the conclusion or result of this architecture based on and general architecture characteristic rating of this layered architecture characteristic rating for different architecture characteristics or quality attributes. So if we will take a look here, we can see that, for example, deployability, what means 1 star and 5 stars? 1 star, as in, I suppose you guess it like low. So you shouldn't choose this architecture style or this pattern if deployability is important because it have just only 1 star. So it means quite low rating, not a good choice to choose this layer. So, and to deploy the monolith application is quite a big issue because the amount of code is a big. So it's not the best choice to choose if you will deploy frequently, and it should be quite fast. Elasticity and scalability rate are very low for layer architecture, so it's quite hard to scale this layered application and to make as much ports as needed. So moreover, in most cases, it's not Dockerized solution. Fault tolerance, layered architecture don't support fault tolerance due to monolithic deployment and the lack of architecture modularity. So also it's not the good choice. The overall cost and simplicity are the primary strengths or for the layered architecture style. So this is the strong things that have these styles: the overall cost and simplicity. It's quite simple to implement, and you can implement it quite fast. It will not cost for the customer quite a lot. Reliability rates medium in these architecture styles. mostly due to the lack of network traffic bandwidth and latency found in most distributed architectures. So if we'll take a look for testability have deployability, both deployability and testability quite low for this architecture style. So because you will have a lot of amount of code, it will be hard to test all of them when the change is happening. What else is that? So as a conclusion, as you can see, for which situation it's preferable to choose layered architecture style, layered architecture. When you see that after you communicate with stakeholders, with all of them, and you range all of the concerns of quality attributes, you have prioritized them, and you will see that most important is cost and simplicity. You have to deliver it quite in short term. Then what kind of architecture style pattern you can choose is this one. Layered architecture style is a good choice for small, simple application or websites. It is also a good architecture choice, particularly as a starting point for a situation with a very thin budget and time constraints. So if you will hear, we don't have a big budget and we have time constraints, we need something cheap and quickly, then you can propose to move on this direction. As application using the layered architecture style grow, characteristics like maintainability, agility, testability, deployability are also will be affected. So if we're talking about the quite a big application, big systems, large application, using layered architecture might be better suited for other more modular architecture styles. So it will be good choice for quite big, large systems. That's all for layered architecture. And next we will take a look to the pipeline architecture.